Now let us look at how to find the area using polar double integrals. So when you are given a region R in the xy plane, so we have defined area as a double integral. So area is given by f of xy equal to 1 edukka. Then when you take the double integral over R dA, that denotes the area under the area uh, of the region R in the xy plane. Now as you know, dA is equal to R dr d theta. So when you evaluate the integral double integral over R dr d theta, that gives the area of the region R in the xy plane. So here we need to find the limits of integration for R and theta. So this is how we find area of a region R as a polar double integral. So that is double integral over R dr d theta. So let us look at an example of finding polar integral. Use a polar double integral to find the area enclosed by a 3-petal rose R equal to sine 3 theta. Now here n value is odd. If n odd there will be n number of petals and theta will vary from 0 to pi. So the 3-petal rose will have this shape. So we will have the first petal here and then the second one, and then you will have the third one here. So the total angle, so theta is varying from 0 to pi, and you will have 3 petals. Now when you take area, so area will be double integral over dA, so that is double integral over R dr d theta. So this will be equal to, so the radius will vary from 0 to sine 3 theta, and theta is varying from 0 to pi. So we will get integral 0 to pi, integral 0 to sine 3 theta r dr d theta. So that is integral 0 to pi. So we will get r square by 2, integrating r square by 2 varying from 0 to sine 3 theta. So that is integral 0 to pi 1 by 2 sine square 3 theta d theta. So this is equal to 1 by 2 integral 0 to pi. Now sine square theta 3 theta is 1 minus cos 6 theta by 2 d theta. So we'll get 1 by 4 so we'll get theta minus sine 6 theta by 6 from 0 to pi. So the value is going to be 1 by 4. Now at theta equal to pi and 0, so pi il matre idu non-zero avullu, baaki ella values 0 aayirikkum. So the area is going to be equal to pi by 4. So that is the required area of the given region. The problem is to use a double integral in polar coordinates to find the area of the region enclosed by the cardioid r equal to 1 minus sine theta. Now the cardioid will have this shape. Okay, so we have r varying from 0 to 1 minus sine theta, and for cardioid theta will be varying from 0 to 2 pi. So therefore the area of the region will be equal to double integral over r dA. So that's double integral over r dr d theta. So our region is the region which is bounded by the cardioid. So r varies from 0 to 1 minus sine theta, and theta is varying from 0 to 2 pi r dr d theta. So we'll get integral 0 to 2 pi. So when you integrate with respect to r, so we'll get uh, r square by 2 from 0 to 1 minus sine theta d theta. So that will be equal to integral 0 to 2 pi for 1 minus sine theta whole square by 2 d theta. Okay. Now expanding this, you will get 1 minus 2 sine theta. So let me take 1 by 2 outside. About 1 minus 2 sine theta plus sine square theta d theta varum. So that is 1 by 2 integral 0 to 2 pi 1 minus 2 sine theta plus 1 minus cos 2 theta by 2 d theta. So upon integrating, we will get theta plus 2 cos theta varum plus 1 by 2 into theta minus sine 2 theta by 2 from 0 to 2 pi. So applying the limits, you will get 2 pi. The 0 ലും 2 pi ലും വരുമ്പോൾ 1 minus 1 0 ആവും plus 1 by 2 into again 2 pi for sine 2 theta also the limits will be equal to 0. So we will be getting 1 by 2 2 pi plus pi, so that will be equal to 3 pi by 2. So that is the value of the integral. Problem is to use a double integral in polar coordinates to find the area of the region R in the first quadrant, which is bounded by R equal to 2 and R equal to sine 2 theta with pi by 4 less than or equal to theta less than or equal to pi by 2. So we are given two curves r equal to 2 and r equal to sine 2 theta. R equal to sine 2 theta, their n is even. അപ്പോൾ 2n petals ഉണ്ടാവും and theta will vary from 0 to 2 pi. Now r equal to 2 will be a circle of radius 2 which is centered at the origin. So the when you take the petal, so this is going to be r equal to sine 2 theta and we will have the circle r equal to 2. Now we need to find, okay, so this will be r equal to, sorry, theta equal to pi by 4 and theta equal to pi by 2. So we need to use a double integral to find the area of the region, the first quadrant, that is bounded by r equal to 2 and r equal to sine 2 theta. So we need to find out area of this portion. So therefore here r will vary from sine 2 theta to 2 and theta will be varying from pi by 4 to pi by 2. So therefore area will be double integral over r dA. So that will be double integral r dr d theta. So when you apply the limits, you will get integral pi by 4 to pi by 2 sine 2 theta to 2 r dr d theta. So that is pi by 4 to pi by 2 varum r square by 2 from sine 2 theta to 2 d theta. So applying the limits, you will get, so let me take 1 by 2 outside. അപ്പോൾ pi by 4 to pi by 2, 4 minus sine square 2 theta d theta വരും. Now this can be written as 1 by 2 integral pi by 4 to pi by 2, 4 minus 1 minus cos 4 theta by 2 d theta. Now upon integrating we will get 1 by 2. Okay, അപ്പോൾ 4 theta വരും. 4 theta minus 1 by 2 into theta minus sine 4 theta by 4 from 0 to pi by 4 to pi by 2 ആയിരിക്കും വരുന്നത്. Limits pi by 4 to pi by 2. Now applying the limits you will get 1 by 2, 4 pi by 4 വരും minus 1 by 2 തീറ്റയ്ക്ക് രണ്ട് വാല്യൂസും കൊടുക്കാം. അപ്പോൾ pi by 4 വരും. Then plus 1 by 8 sine 4 pi by 2 വരുമ്പോൾ 2 pi വരും and minus sine 4 pi by 4 that is pi. അപ്പോൾ രണ്ട് വാല്യൂസ് 0 ആവും. So we will get 1 by 2 pi minus pi by 8. So that is 1 by 2 into 7 pi by 8. So that is 7 pi by 16. So that is the required area.